This instructional video was put together so you could diagnose any problems you might be having with either the Okin or Limoss power motion systems. Now the parts in both Limoss and in Okin are almost identical. The only difference is the shape of the motor housing. I'm going to now go through each component and describe them and briefly discuss what kinds of problems you could have with them. The first component, of course, is the power cord. It's a standard figure 8 power cord, and figure 8 is defined by the end here. Now, because these systems are sold internationally, the transformer will work with both 110 all the way up to 240 volts. If the customer moves to another country, they simply buy a new figure 8 cord, get rid of the North American end on it, which will be on the cord, and can use a standard Asian or European end. The next component is the transformer. The transformer is located either outside the unit or up in a bracket inside the unit. This is a standard transformer, and there's a green light right here that you will notice when it's plugged in and working. On the back side are the specifications of the transformer. We'll get into how to read the voltage on these transformers later. The next component is an optional component. This is called the Y connector. The Y connector is used when you have multiple, actually two, power units working off of one transformer. This is common on love seats and sofas. The next component is the switch. Currently, most popular in the marketplace are two types of switches. This round switch, which is located either on the inside or outside of an arm, and this lever switch, which would be located on the inside of the arm or next to the seat cushion in an armless power unit. And of course, the final unit is the motor. This motor is attached firmly underneath the unit with either 4 or 6 bolts. You can always tell the brand because it has a label on it indicating the voltage range, and it has the cord coming out of it that connects to the transformer and a place for the switch to be plugged in. Now the very first thing you want to do is make sure that you have a good power cord. You'd be surprised how many times this power cord gets placed up inside the mechanism and cut. So first inspect the power cord. Make sure it's not cut. Also make sure the outlet it's plugged into has electricity going to it. Once you've determined that, what you need to do is go through and check all the connections. We find that most of the problems are the connections. Now this plugs in, the end of the power cord plugs into the back of the transformer. And when it does, this little green light right here will light up. You'd also be surprised how many times it looks like it's plugged in, but it's not plugged in. And that happens all too frequently. If the unit is equipped with a Y connection, make sure that the Y connection is connected. You would also be surprised how many times, for whatever reason, this connection will work loose. Make sure that the other end of the Y connection is connected to the motor. Inspect the Y connection. Make sure it hasn't moved and hasn't been accidentally cut by the mechanism. And finally, make sure that the cord coming from the switch is connected to the motor. You would also be surprised how many times, for some reason, this little plug will get pulled out. If after you've checked all the connections, you've made sure that there's power, and the unit is still not working, then it's time to diagnose what the problem is. To do that properly, you will need 3 tools. You will need a spare power cord, a spare switch, and a voltmeter. If you don't have a voltmeter, make sure that when you buy one, you get one that has prongs on the end that also are reduced to a little bit of a spade so they can fit inside the outlet cord of the transformer. Also, if you've not used a voltmeter before, make sure you read the instructions. Another good idea with voltmeters is make sure that you turn it off when you're done using it. They're powered by a 9-volt battery, and if the battery goes dead, it's really frustrating to be on a job site and not have an active voltmeter. The other thing on voltmeters that gets a lot of people in trouble, make sure that the connections to the leads are firmly plugged into the voltmeter. Once in a while one will get loose, you won't get accurate readings, and you'll have a misdiagnosis. Now a little bit about the voltmeter. We're going to use two settings on the voltmeter. We're going to use DC volts and we're going to use ohms. Ohms measures resistance. So when you use a voltmeter on ohms, you can test a cord like a power cord. You can test each wire in the power cord and see if it's good. On DC volts, we will measure the output of the transformer. Always make sure when you're testing DC volts on the transformer that the voltmeter is set higher than the output of the transformer. So for example, if the transformer is putting out 29 volts and you have it set on 20, you will not get an accurate reading. In this case, we have set the DC voltmeter to 200 volts. We will set the ohm meter to 200K. With our voltmeter turned on, set to ohms, and set at 200K, it's now time to test the power cord. What we're going to be doing here is testing each wire in the power cord. Put one end of the voltmeter test prong into the figure 8 end. Take the other end and touch it to the prongs that go into the wall. Now in this case, I touch it here. You see the voltmeter stays on 1. I move it over here, it goes down to 0. 0 means there's resistance and it's a good wire. Move it over to the other prong and do the same thing. It goes back down to 0. This is a good power cord. Now that we've tested the power cord, it's time to test the transformer. When the transformer is plugged in, you will notice that there's a green light that's turned on. But we want to check the voltage coming out of it. So we put our ohm meter on 200 volts DC. Anything greater than 30 will work. On the end of the transformer, you will notice that there are two spade openings. The big one is the negative or black lead. You press that in there, and once again, you should make sure that the ends of your leads are such that they will fit in here, that they're spade connectors. Put the other end into the other side, and as you can see, we go up to 29.2 volts. This is a good transformer. The range of voltage on the transformers is 24 to 29 volts DC. Now that you've checked the power cord and the transformer, if it's equipped with a Y connector, you want to make sure that you have voltage to the ends of the Y connector. You can test this connector one of two ways. You can do it by measuring the DC voltage coming out of the ends, or you can go back and use the ohm resistance test on this line. If at this point the motor is still not working, you've tested the power cord, you've tested the transformer, you have tested the Y connector if so equipped, then the next step is to test the switch. What you want to do is remove the switch installed in the unit, plug in your test switch. Once you have your test switch in, you can test the unit, and you will see in this case it now works. If it had been the switch, then you need to replace the switch. If after putting in the test switch it still doesn't work, then what you have is a bad motor. So I hope this will help you diagnose the problems you are having with your power motion. Once again, just to recap, first, make sure you have power to the outlet powering the unit. Second, make sure the power cord's good. Check all the connections. Then go through the diagnostic tests. Test the power cord with your ohm meter. Test the transformer with your DC voltage meter. Make sure that the Y connector's good. Make sure the switch is good. By then you've eliminated everything but the motor. Thank you for watching.